The pace of global climate change is higher than feared, and we all can see the implications. We as a society are responding to this development with the energy transition by making the necessary changes to our power supply. Instead of using conventional power plants as until now, we are expanding the generation of electricity from renewable sources, but often these are installed far away from the places of consumption and offer little flexibility, since there is no control over when and where the wind blows or the sun shines. This enormously increases the complexity of stable grid operations. Why? Because as conventional power plants are being decommissioned, transmission system operators like TenneT are lacking a vital tool for balancing unexpected deviations between generation and consumption. If we are to safeguard our reliable electricity supply in the long term, we need more producers, storage facilities and consumers that are capable of responding flexibly to fluctuations in the electricity grid. In the Digital and Flex Development Division, we at TenneT think beyond the energy sector's boundaries. Our goal is to develop such flexibility potential with partners from different industries. Integrating small, decentralized plants for grid stabilization purposes is a major challenge. That is why TenneT is developing the Equigi crowd balancing platform together with other European transmission system operators. With the help of the platform, providers will be able to place their flexibilities on the market and make them available to grid operators and market players in a secure and unbureaucratic way. One particularly fast-growing source of flexibility is being created by intelligently charging and discharging mobile storage systems in electric vehicles. The new German federal government's target is 15 million electric cars in 2030. What's more, the sensors integrated in modern passenger vehicles can transmit data that is important to the energy sector in real time, thereby increasing the quality of renewable energy generation forecasting. Residential buildings and private households can also help to make the energy system flexible. A digital, intelligently connected community enables flexible operation of heat pumps, combined heat and power plants, and photovoltaic battery storage systems, which can, for example, store surplus electricity and thus relieve the pressure on the electricity grid. Digitalisation is also opening up new major sources of flexibility. Companies can flexibly adjust the volume of electricity bought for energy-intensive consumers, and by doing so, obtain cost advantages. Also, local, long-distance and freight transport all promise a tremendous amount of flex potential, with around 10 terawatt-hours per year. At the same time, the railway electricity system is flexible enough to reliably compensate for the extreme daily load fluctuations, especially during rush hours. This already existing flexibility in the railway electricity system can also be used for the public power supply grid. Deutsche Bahn's own electricity grid is connected to the public grid by means of converter and transformer stations. By flexibly distributing the load and controlling the amount of electricity purchased, DB Energie and TenneT can eliminate local bottlenecks and thus balance the public grid. Flexibility is the missing link in renewable energy systems integration. It creates new business models that help to make the energy transition a success. We are completely convinced that there's far more unrealized potential because sources of flexibility are everywhere, in every sector, in every size, and they are all important. Reach out to us, because the energy transition will only be successful if we work together.